All right, thanks for coming. Chris Phillips from Carnegie Mellon. We'll talk about baseball and statistics.
Indeed. So thank you to Harry and Glenn for inviting me. Looking at the roster of talks this semester, it's nice to be a historian on such a distinguished roster. And it's also, I hope you don't mind, not only am I bringing a historical perspective, but I'm bringing a historical perspective on a kind of déclassé topic in the history of statistics, which is to say the history of statistics as they're used in something like baseball. And so when I was finishing another project a couple years ago, this guy here, Craig Biggio, was up for election to baseball's Hall of Fame. And as you can imagine in this sort of setting, people put forward arguments about how good a player he is. And these arguments sometimes take the form of numbers, how many doubles he hit, how many home runs he hit, what kind of average he has. And other times they take narrative forms, what we might think of as subjective arguments about the fact that he was steroid free, that he was a good teammate, that he was a quality player over a long career. These kind of simplistic divisions. And what I want to suggest, especially if you don't know who Craig Biggio is, which is no problem at all, what I want to suggest is that this is a general problem. This is something we deal with in many fields: history, statistics, probability. How do we move from knowledge of the past to make evaluations about decisions in the present and determinations about value in both the present and the future? That is to say, how do we use data? Now, if it's a general thing, if it's a general issue, part of the reason why it's general is because in the popular imagination, baseball has become the central mode by which data analysis enters the public mind. And so if you poll people on where they think of data, how data affects their everyday lives, how data decisions have changed the way we make decisions broadly, the effect of Michael Lewis's 2003 book Moneyball, and then the film just a few years ago based on it, loomed very, very large in this kind of discussion. And indeed, it was never just about baseball. So from the very beginning, it was immediately acknowledged to be a much wider cultural phenomenon. So the Harvard Business School within months used it as a case study in leadership. There's Moneyball from government, for government, from Peter Orszag, who is a high-level government official in President Obama's administration. There's Moneyball for education, Moneyball for policing. This is now a general way in which statisticians and data scientists are gaining employment in all sorts of fields, that the way decisions are made in baseball should be the way we make decisions in all kinds of complex areas. And so for me, what I was interested in part, is to think about, if it's such an important area, why don't we know more about where numbers come from in baseball? And why don't we care more about the history of statistics in something like baseball? And I think if you're wondering why baseball, for me at least, one answer is that it is the classic example of a numbers game. So we were talking about game theory earlier, and the idea of a game being evaluated through numbers. Baseball is one of the earliest examples of that. But it's also, I think, the kind of public figures for data analysis. So somebody like Nate Silver began his career in baseball and now is taken as a general speaker. And for something, again, in the kind of more popular aspect, so how big data increases inequality. This is a book that came out just 2 years ago, Weapons of Math Destruction. And for someone like Cathy O'Neil, baseball is the good way to use data. That you shouldn't use data to determine job applicants, you shouldn't use data in credit scores, but you should use it in baseball. It's fair, it's transparent, it's powerful, it's rigorous. So this whole talk is coming from a book that should appear, God willing, in the next 12 to 18 months from Princeton called Scouting and Scoring. And basically I ask two questions in that book. And the first is, how do these scouts and these scorers, that is to say, people who think about bodies and people who think about numbers, determine quality in baseball? How do they evaluate baseball players? And the second part of it, which is more of what I think we'll be talking about here today, is what is this story, or what do these stories tell us about the history and the meaning of data analysis in the modern world? What do we learn about data by thinking about something as mundane as statistics? And we're not talking about Bayesian analysis here. We're talking about adding, subtracting, dividing. We're talking about averages. We're talking about a very low-level use of statistics, but nevertheless, a highly visible and consequential one. So the basic way I approached these questions was to ask how something like Biggio's skill level, or the number of hits he recorded over a career, how those become facts. So for historians of science, this is a classic question. How do facts get made in this kind of mundane way? And I'm going to talk today about two numbers, and you should feel free to interrupt at any point to ask questions, or if I assume knowledge of baseball that you do not have. But the first number I'm going to talk, or the second number, excuse me, I'm going to talk about is what's called an overall future potential. And it's on almost every scouting report that comes out about a player. And I'm interested in this number because it essentially reduces humans, it reduces somebody like Craig Biggio here to a single number, in this case 65.5. So where does this number come from? How does it get created? What significance does it have? And then the second number is on his career list of totals. It's 668. That's how many doubles he hit over the course of a career. These are obviously different sorts of numbers. One is a count of his doubles, and the other is a single number meant to reduce his entire potential as a major league player to one three significant figure number. Where do they come from? By looking at them together, what do we learn? So let's start with this first number here, 668. One of the claims that was made, about Craig Biggio is that he has the most doubles of any right-handed player in history. This means, for those of you who have never played baseball, he's hit the ball such that he can run 2 of the bases. He's had a double. And he has the most of them of any right-handed hitter in history. And it seems like as simple a fact as you could basically get in the history of baseball. And yet it requires a reliable record going back 150 years. And the interesting thing about a claim like this is that the nearest person to him, so if you look on the list of career right-handed doubles hitters, and these lists exist, the person right behind him is a guy named Nap Lajoie. Nap Lajoie played for Cleveland from 1896 to 1916. And apparently, Biggio exceeded Lajoie's record of doubles by exactly 11. And now there's a lot of problems with this. The first being that Lajoie played before statistics were reliably kept, before there was anything such as a radio broadcast, but also more mundane problems. Lajoie's batting average is currently in dispute with Major League Baseball and with encyclopedias like Baseball Reference. And so how do we know something like Craig Biggio hit 11 more doubles than Nap Lajoie over a career? And what does knowing this tell us about the role of statistics in the modern world? And so I just asked the stupid question. I said, well, where does something like Baseball Reference get their data? Surely they get it from Major League Baseball or from the official statisticians. But it turns out they hadn't. It turns out they got their data from another website that existed in the mid-1990s, put up by a fellow named Sean Layman. Sean Layman, this is, fortunately, websites in the 1990s for historians are very hard. It's hard to get good images of them from the Wayback Machine, but this is what the website looked like about 1997. And from this website, Sean Foreman, who eventually started Baseball Reference, essentially downloaded the entire player statistical record from 1871 to 1996. So what would I do? I naturally called up Sean. I said, where did you get your data? And it turns out Sean stole his data from the CD-ROM that was included by Total Baseball, an encyclopedia published in 1994. He scraped the files off the CD-ROM, recombined them into a Microsoft Access file, and then uploaded it to his website. Now, where did Total Baseball get its record? And it turns out they got it from this guy's home computer, Pete Palmer. Pete Palmer kept the entire database on his home computer, and he still uses this particular formatting. This is from just 3 years ago when I visited him at his house. This is how the record is still kept. And who is Mr. Palmer, such that the entire record of online statistics in baseball is based on his home computer? Well, after he graduated from Yale in 1958, he took jobs in systems and electrical engineering until he landed at Systems Development Corporation. And he was in charge of manning a radar that monitored for potential missiles, unidentified flying objects off the coast of Alaska. And while he had this job, he had a lot of downtime, suffice it to say. And so he was able to look at these two encyclopedias that were coming out in 1950s and 1960s themselves, which had had a series of baseball records. And what he suspected, though, was that these encyclopedias had a lot of errors. And indeed, when he started looking at simple things, like taking a group of players on a team and add up the number of hits they have, does it equal the team's total of hits? If not, there's probably a problem. But he didn't know how to do this systematically. But he had a giant computer. And so he turned those two encyclopedias into 30,000 punched cards. This guy had a lot of downtime. Manning radars in the 1970s, there was just a lot of downtime, especially when no Soviet missiles were actually mercifully sent at that point that he was looking for. And so he typed up 30,000 of these IBM classic 80-column punch cards, and then he ran them through a mainframe computer. Now, as I mentioned before, he was not trying to do advanced analysis with this project. He did have some side projects where he was doing the kind of analytical wizardry that has become associated with baseball and with the kind of modern data analysis. But really what he was doing is checking totals, trying to make sure that the totals in one place summed up to the totals in another. But he discovered a huge set of problems that weren't just that the numbers didn't add up, but also that different sources had different numbers. And so he had the problem that, for instance, for Nap-Lajoie in 1907, two of the sources he used, both of the previous sources, said he had hit 30 doubles. But the books that came out at the end of that season of 1907 said he hit 32 doubles. Now, how do you solve a problem like that? And what I'm going to suggest today is that he solved them in ways that all statistical analysis will solve problems of data, which is to say both technologically and through a human infrastructure. This is the machine that he worked on. It was Control Data Corporation's 6600. It was one of the world's fastest supercomputers in the 1960s. This is the machine that was actually running the Cobra Dane radar that he was working on during his day job. And this machine could execute about 3 million instructions per second. So he thought that was plenty fast to run his data through there and to see if the number of hits added up per season. And so this is actually, it's a little hard to see, but what he did was create printouts for every statistic across the seasons from 1871 to 1971. So 100 seasons worth, the hundreds and thousands of players, and then he'd go through and mark each one every time. This is +1. He thought this was -1, but it turned out to be okay for every single season, every single player across these 100+ years. The man was kind of a nut, but he was a nut who ended up having this kind of statistical database. The second aspect is that he joined this group, a new group in 1971, the Society for American Baseball Research. It's a still existing group, Sabre it's known as. And the reason he joined this group is because he needed people to start hunting down the reasons for these discrepancies in the records. He had to, every time he found a +1, a -1, a +3, a -4, he wanted to hunt down where in the records that discrepancy was created. And so he had what he called gremlins all over the country, going back through local newspapers, going back through the original records that existed, looking at the year-end reports that were published to try and figure out exactly where the discrepancies occurred. What I want to suggest, at least in this limited instance, is that we ought not to think of this as really all that separate from his day job, which is to say what he was effectively doing was a form of data-based science. He was doing something that we're familiar with in history of science in projects like bird banding or baby observation or collection of labor statistics for unemployment records. That is to say, he mobilized a network of lay people and experts in his field in order to collect this data. So it wasn't that his baseball work was kind of opposed to his real scientific work. It was in essence the same kind of work, I want to suggest, that he was doing. But we still really haven't gotten to the point of where these doubles came from, because of course, how did these doubles end up in these encyclopedias? How did they get collected in the first place? And the answer, by and large, is official scorers. So it's not obvious that baseball or any activity produces statistics. Oftentimes we talk very lazily, as if statistics are kind of the detritus that are left after an event, as opposed to something that's manufactured, and manufactured in very intentional and complicated ways. Official scores, or scores as they were known, have been a part of baseball from the earliest days. This particular manual is taken from 1866. This is before any professional leagues existed. This is before any kind of professionalization overtook the sport. And these official scores are in essence are responsible for creating a double. So one way to think about them is that something like a double is a complicated movement of bodies in space. Now someone like an umpire at a baseball game will say that a player is out or safe, say whether or not he violated the rules. But it's the official scorer who provides the judgment on what that particular movement of bodies should be labeled. That is to say, judges it to be a double, or judges it to be an error, judges it as a hit, or as that is a credit to the batter, or as an error, that is a demerit to the fielder. So official scorers from the very beginning were in the business of adjudicating moral credit in the creation of statistics. And early scoring in baseball, even from the 1860s, was always about far more than who should win the game. Official scoring was never about just keeping track of the runs. It was about creating a moral record of baseball going back to 1866. And no one was more influential than this than a fellow named Henry Chadwick. Henry Chadwick was in fact called by Pete Palmer in his published Total Baseball as the great pioneer of baseball history and record keeping. And Chadwick is one of the most important promoters and developers of baseball in this period. He really is kind of the huckster for baseball in the 19th century. And for my purposes, one of the most interesting things about Chadwick is that he came from a family devoted to statistical reform, and in particular a Whig family in England in the 19th century, that is to say kind of what we might call in modern day terms a kind of progressive, who came from the idea that progress, social progress, comes from keeping statistical records. So Henry Chadwick's older brother was Edwin Chadwick, who is most famous for the report on the laboring population in Britain. This is the kind of foundational document of public health. It was the public health statistics in Britain from 1842. This is a second edition published in 1843. And both Edwin and Henry Chadwick had faith in the idea that keeping a statistical record is the way to reform a particular activity. So if you want to reform a city, you keep a record of the health of that city, of the people in that city. If you want to reform a game, you keep a record of what happens at the game. Before Chadwick got involved in baseball, the statistics were generally just kept internally by teams. So this is from 1845. This is the Knickerbocker Club from Brooklyn, New York. I shouldn't say that. From either Manhattan or Brooklyn, which are separate cities at this point. From either Manhattan or Brooklyn, the Knickerbocker Club. And here are the records they're keeping for their own team in 1945. Fairly basic. And what Chadwick wanted to do is take this internal record keeping and turn it into public statistics. That is, turn it into something that could be used to keep a record publicly of baseball performance. Chadwick was not satisfied, however, with any sort of statistical analysis. He wanted his own form of statistical analysis. And so in his newspapers, in particular in the New York Clipper, this is from 1860, he proposed the exact method by which data should be kept in baseball games. And he called this the correct score of a baseball match. And so, as you can tell, he not only is keeping track of hands lost, which is another way to say outs, and runs, but he's also keeping track of runs per inning, and then the character by which every person was put out. And then, on the other hand, the way every person actually put out a player. So you have a record on both sides of how the team was able to perform. That is to say, the data on which you'd keep track of the performance of baseball.
Where's the pitcher?
The pitcher. So, interestingly enough, he was not interested in pitching statistics. So the pitcher in 1860 had played almost no important role because pitching was either done underhand or even when it was done overhand, you got to request where the ball was thrown. And so to him, the pitcher was not an interesting part of the data of baseball. The data of baseball came entirely from fielding and from running around the bases. And so this is one of the things you immediately start noting when you start to pay attention are the ways in which you can track what counts as important, or what counts as morally significant in baseball by what kind of statistics are kept year after year.
So could you foul out at that time, or were there strikeouts? It says foul ball on that. Right?
Yeah, exactly. So the foul ball actually. So one of the you can get out on foul balls. The rules are slightly different. So for instance, you can if you catch a ball on a bounce, whether it's fair or foul, it was still an out in 1960. Or in 1860, excuse me. So the rules are, so that's part of what, not only do they keep track of fly or bound, whether you catch a ball on the fly or on the bounce, but also they keep track of whether it was in or out when it was caught. And of course, where they got tagged out on the bases. So you can imagine this kind of thing was kept, and you can keep it to any degree of sophistication you wanted. So this was his first suggestion, that at a minimum, you should be keeping data at this level. You should be keeping not only who gets out versus who scores, that is to say, successful and unsuccessful performance, but also what he called the character of each performance. He was very concerned with trying to characterize every performance. After this came out in 1860, one of the things Chadwick promised was that his newspaper would publish the complete reports of all the baseball teams. And so one of the most interesting things for me about this era is that it was never about private statistics. These were public statistics. These were meant to form a kind of public record of the game. So they were not internal record keeping. It was absolutely something that was meant to become general knowledge here. And part of the reason is, of course, it sold newspapers. Newspapers print statistics because it enables them to give year-end awards to the best players, the most morally successful players, the most skilled players. And this sells newspapers. Statistics and statistical record keeping from 1860 to the present has been widely acknowledged to be a way to sell papers. And so when you write the kind of whatever the listicles that we'll see on the kind of top 10 of this or that, from that day till now, people know that that creates debate, and debate sells papers. And so this is precisely the kind of public justification or the justification within the company, within the newspaper, for including this statistical analysis. The other interesting thing from my perspective about Chadwick is that he saw it explicitly as double entry bookkeeping. So when he thought of baseball record keeping, he thought of it as simultaneously recording credits for one team and demerits for the other. So every hit was a hit allowed, every error was an error allowed. And so he made careful recording to keep good plays in the field separate from plays at bat, and then they could all be summed across the bottom. And so you could be sure that every single play was recorded on both sides of the ledger by making sure they summed up, in this case to 27 outs, which is the typical baseball game by the 1860s, 9 innings, 3 outs per inning. So you'd have a 27 on both sides of the ledger. And of course, he thought if you were going to keep data, it had to be recorded in a uniform manner. And so he sold his own score sheet as a convenient way to make sure that data was kept in a uniform manner. And so he would sell this to teams looking to keep score. Now, we still haven't addressed the question of what sort of person the scorer is, which is yet another aspect that he was concerned about. And for Chadwick, a scorer should be one whose gentlemanly conduct will render him acceptable to all who are liable to make inquiries of him relative to the score of the game. And this should ring a bell in the sense that gentlemanly conduct was in part a gesture at a kind of English philosophic and scientific tradition that gentlemen are the ones who keep score because gentlemen can apportion credit. That is to say, they have the standing, the remove, first of all, they're male, and second of all, they have enough money to not be influenced, to not be able to be bribed. And so when he's talking about the gentlemanly conduct of scorers, in essence, what he's doing is saying they have a guarantor or guarantee of being independent, of having an ability to make judgments fairly in an unprejudiced and honest way. At no point did Chadwick ever distinguish skillful from morally worthy. For him, these things were the same question. The statistics he kept, he thought, were the statistics which would reveal whether baseball was in fact becoming more moral, manly, and scientific. Those are the three hopes he had for baseball, is that over time it would be moral, manly, and scientific. And keeping of statistics was the way to ensure that baseball was progressing toward an ever more moral, manly, and scientific field sport. Chadwick, as one other historian has put it, essentially turned the idea of record keeping, and here's actually one of his hand scorebooks from the 1860s. He turned record keeping into a mini morality play. He saw it as this kind of conquest. Who succeeds? Who fails? Who is the good, the kind of hero of the day? And so he meant for his plays to be read back. And so these are kind of details from that. And you can see at every point he's keeping track of what's good, what's not good, what should be honored and valued, and what should be complained about. So muff is just an old-fashioned 19th century term for an error, by muffed throws or wild throws, by balks and called balls. These are problems. These are things that need to be reduced over time. So how did these kinds of score sheets then become public records, right? How did they go from being newspaper records to being something that was then recorded on year-end summaries and eventually into encyclopedias and into databases? And the reason is that the leagues themselves wanted control over these statistics. The leagues were worried that if newspapers controlled statistics, if they were controlled by private entities, the leagues wouldn't have control over who was actually keeping record of the game. And so starting from the very first year of the National League in 1876, which is not the first professional league, but the oldest still existent professional baseball league, from the very first year in 1876, their rules specified that scorers, which were appointed by the home team in every game, had to mail within 5 days of the conclusion of the game an official score sheet listing every statistical or tabular category, as they called it, that the league demanded for each of their games. And then these would be kept actually in the office. And so my kind of example of this is a fellow named John Heidler, who was secretary and president of the National League. And John Heidler, as secretary, was the person responsible for taking these inputs of data, these inputs of statistics, and turning them into official league records. And so we have an account of him doing this from 1913. Luckily, somebody visited his office and wrote about just how wonderful his system of record keeping really was. What he would do is he would take reports from scores and newspaper accounts of the game. He'd cut them out, he'd paste them into a giant ledger day by day, and then he would keep record. One page would be for team performance, and one page would be for each of the individual players. And he record home teams in red, home games in red, away games in blue, and then over the course of a season, he'd be able to keep track of it. So this is what they look like, these giant ledgers. This is within the Baseball Hall of Fame in Cooperstown, New York, and basically these giant ledgers exist going back to about 1913. And that's how statistics were kept at the office in this, what was called a daily or a day-by-day ledger. He had 35 statistical categories for every single player to try and record the performance over the course of each game. And so this provides, I think, a good reminder. When we say things like official statistics, we mean of the office. We literally are pointing to a bureaucratic function in which official statistics are distinguished from unofficial statistics, not on the basis of quality, but on the basis of where they're kept and who's keeping them. And this is an important reminder, I think, much more broadly, but baseball is a good example of this. So though the system has changed over the last 100 years, essentially all the key ingredients are in place by about 1913. So at the end of a game, somebody appointed by the home team but paid by the league will fill out a report. This is from 2015. This is still the same statistical report that they're using in 2015. And they will fill this out. Now they don't mail it, now they fax it. Hilariously, they still don't scan it, they still fax it. But they fax it to the league office, and then the league office now will input these into a giant database. It is no longer written down, sadly, but input it into a database and keep track. So in effect, effect, it's been the same system for a little over 100 years. And so we can ask, where are doubles? So we're going back to that question of these doubles. So where are the doubles? And one answer is that they're written on the sheets, these sheets that are sent in from official scores after every game. Another answer is that they're tracked in these ledgers, that they're actually physically present in the ledgers over the course of a season. Of course, they're collected in commercial newspapers, and then they're punched into these IBM cards by the 1970s, these 80-column cards. They're printed in official encyclopedias. They're put on a CD-ROM where they're scraped and then uploaded as Microsoft Access files, and then downloaded and re-uploaded as a database online that now can be queried from any computer in the world. And the reason why I want to emphasize this is in one point, just to make a simple statement about facts and statistics being physical objects. They are physical in the sense that they have physicality. They don't exist except for this physical infrastructure. And one of the consequences of being physical is, of course, there's friction. If you want to move them, if you're transporting them, if you're preserving them, just like every physical object, you have to overcome hurdles. You have to think about problems of logistics and problems of preservation. But it's also, I think, just to remind us, in fact, that the stability of something like 668 doubles is an accomplishment. It actually takes an immense amount of labor and work to create the essence, this kind of number on a computer screen that can be recalled seamlessly, hides the labor that goes into its creation in a real way. Now, there's a fair argument to be made that this is all wonderful for early 20th century, but nowadays aren't statistics kept on computers instantaneously for every game? Surely this isn't the same kind of system that we keep for this. And there's a good argument to be made. So one of the things I had to do is actually go into where statistics are kept now in the 21st century. And these are the offices of Major League Baseball Advanced Media, or BAM, as it's awkwardly known in the field. And BAM has offices in Chelsea Market. They placed them in Chelsea Market in Manhattan because it's right on the information superhighway there along 8th Avenue. So Google's across the street, so they have access to all the streaming because they run all the streaming services for Major League Baseball, as well as for HBO, for ESPN, for World Wrestling, and they were just bought out by Disney, in fact, to do their streaming as well. Let me get this. And in these offices, how do they keep data? Well, it turns out BAM didn't create its operation overnight. They actually stole their, I mean they just waited until this crash here in mid-2000, and then they bought right there the operation from a little-known company called Quokka, which was keeping one of those internet bubble companies that existed for a grand total of 3 years between 1998 and 2001. And they took their data operation from Quokka. And Quokka itself had taken its data operation from Total Sports, which existed in the mid-1990s, and Total Sports had taken it from a little-known project called Project Scoresheet, which goes back to the 1980s. And so, in fact, something like Major League Baseball Advanced Media, which seems to have this kind of cutting-edge infrastructure, has based its entire infrastructure on a project to gather baseball data, again going back to the 1980s. And this is what Project Scoresheet originally looked like in the 1980s. Now, why do we care that they have this kind of historical dimension? I think we care not just for the purpose of knowing where the data comes from, but we also care because it helps push back a little on some of the rhetoric of the importance of computing and high-speed electronic computing in particular to the history of statistics and the history of data. It helps to remind ourselves the ways in which the infrastructure of computing is actually built on much older paper technologies going back decades. And so it's another kind of case study in the ways in which it might seem as if high-speed computing with almost unlimited storage capacity changes the way data is kept, the way data is analyzed, but actually on the ground it has a much older history. Project Scoresheet was started by a guy named Bill James, who later went on to become the kind of guru of statistical analysis in baseball. If people know one name associated with statistical analysis in baseball, it tends to be that of Bill James. And Bill James started it because no one was keeping track of statistics play by play. As we talked about, so people kept track of statistics in essence by keeping track of what happens to each person at bat. And so if you're in this particular batter, essentially if you get a hit, you then go to first, and then if you steal a base, you then go over. But when you steal a base and when you get a hit, the temporal connection may be actually quite distant. No one cared because all they cared about was what you accomplished as a baseball player. And so one of the tricks is turning the baseball game not from a collection of who does well and who does poorly, but into a series of inputs on a computer, into a series of ways of recording the game one event at a time. And how did this take place? Well, the first answer I want to say is through a kind of human infrastructure. That is to say, keeping track of data then and now requires a lot of people spread around the country. So Project Scoresheet, when it was first created, had a human keeping score in every stadium and a second score at home watching on TV to make sure that their scores would align. They would keep track of each score, they would input it onto usually a physical score sheet, and then they would mail it in, and it would be inputted into a computer play by play, as if the game were happening in real time. Obviously nowadays they do this on a computer as a game is happening. They have the ability after the 90s to have a kind of modem-based connectivity, so they submit the scores after every half inning in the 90s. Nowadays they do it instantaneously. But the same idea is present, that essentially baseball scorekeeping is a surveillance operation. And the fellow in charge of it, who has the enviable title Vice President for Statistics for Major League Baseball, the fellow in charge of it essentially runs it like a casino. It's explicitly a surveillance operation. So the way he describes it, this is Corey Schwartz, is that there are stringers in the park who deal the data. They deal the cards of the data. And then there's managers, who he calls pit bosses, who sit here and watch the data being uploaded onto the screens as the game's being played. And so they monitor these people inputting the data. And then there's what he calls the eye in the sky, or the adult in charge, who stands behind them right here and watches the managers watching the game to make sure the data is uploaded correctly. And then he has the count room, which is a final layer of management in New York, which goes through the entire day's statistics every morning at 4 a.m. before sending them out to all the teams at 6 a.m. once they're cleaned up. So there's a huge human infrastructure involved in what seems to be this kind of seamless tracking of data pitch by pitch that comes in. And this is all invisible, of course, to the record of the game appearing on a computer. Yeah, here.
So it's pitch by pitch. Is that what the unit of time is?
Now it's pitch by pitch, yes.
So, and they record ball and strike, I assume.
They record actually everything about it. They record
if, I guess that's why I asked pitch by pitch, throw over to first base.
That's an excellent question. So originally, no. Originally, they just recorded pitch by pitch. About 4 years ago, they bought a tracking system, a Doppler-based tracking system that records, it's both Doppler and video-based, in fact, and that will record the movement of every ball. And so that's where all the new kind of, I don't know if you ever watch a baseball game now, they'll say the speed of every ball thrown, regardless of where it's thrown. They have down to 3 inches, the location of each ball, the rotation of the seams on the ball, and the ways they move through the air. But these all got mapped onto the pitch by pitch sequence. So each pitch is given a GUI, a kind of unique ID, and then they map on all these additional measurements to each span of a pitch. And so it's the same system that they were developing pitch by pitch, but they've just mapped onto a series of data on top of it.
So at 4 a.m., if somebody is control check at 4 a.m.,
Mm-hmm.
if something doesn't make sense, if they can't reconcile something, what do they do?
So now they keep the games recorded. They'll go back and watch the games. So anything that gets flagged, so for instance, if someone says a hard hit ball that goes only 2 feet, something like that would get flagged, and then they would go back and watch the video to see why that got recorded as a hard hit ball that only goes 2 feet. So all that's done by hand to clean up every bit of data that they send out. Do you have another question here? So that's the human infrastructure. The other side of it is thinking of the technology, and here I want to think not just a technology of like high-speed internet or high-speed computing, but also something like a score sheet as technology. So oftentimes we miss the ways the most consequential technological innovations are the ones that become invisible. The textbook, the chalkboard, and in this case, certainly the score sheet. And so this score sheet was invented for Project Score Sheet in the 1970s into the 1980s. And the idea is that with a new score sheet, now instead of keeping track of one player's events, what you do is you keep track of events as an input. And so events get recorded not by who did them, but by when they happened in the game. And this is the key to turning baseball into a computerizable game. In other words, a game that the main purpose of the input is not to record success or failure of every player, but rather to record play-by-play activity. And so the whole nature of baseball statistics were transformed. And as part of this, they actually created a whole new system for keeping track of the data. So in 1985, an entire game, every pitch, every event of a game took about 5 kilobytes of data, which was important. Total, I should say, a whole game took about 5 kilobytes of data, which is about as big as they could have handled in the mid-1980s. So they need to be able to reduce a game to a series of alphanumeric symbols with a few extras thrown in. The significance for me, though, is that this system was bought repeatedly through that whole chain. So today, if you look at what's sent out to major league teams every morning, it's the same code infrastructure is sent out that they invented in 1985. They use exactly the same symbols. They use exactly the same code structure to send out to games. This is from a 2015 game, and here you can see it's a called strike, and then a ball, and then a play happens on the third pitch, and it's a fly ball to left field, to the center part of left field. Whereas this one is a ball, called strike, and then an event here, E, and it's E instead of X because it's a non-out recording event. And here it was a home run hit between center and left field on the fly. And so it's the same code that they were using in the mid-1980s, again, is the backbone of its current data gathering operation. So this, I suggest, is the kind of real backbone of modern big data, are the ways in which, if you kind of hone in on the actual structures, the actual technologies, it's continuous over the last 20 to 35 years. Yeah, Jamie.
I just noticed out of self-interest the weather on
Yes.
the previous slide as well, and I wondered to what extent that was quantified or calculated. Was it purely descriptive, or did that factor into some sort of algorithm or calculation in the broader world of statistics?
Yeah, so in here they didn't do much with it originally. They tried to keep track of it because they wanted to know if different teams and different players did better in certain conditions. And so they would have labeled this kind of as what we'd call metadata. They didn't call it metadata, but they would have labeled it as metadata for each game. And so you could call, even in the 1980s, you could call up every 85-degree plus game in dry conditions and then call up every play that happened during them. And the same infrastructure is here now. So you see 72 degrees, and then the weather's labeled as dome since it was played inside. And so it's a similar kind of infrastructure where they want to be able to call up every similar kind of event. And here you can tell, actually, they have the data caster is listed, so that's what they call their data gatherer. They call it data caster. Doug Anderson did it, and then you have the home run, umpires, and then the official score is also listed. So it's still keeping track of each inputting aspect. And so you can pull up all of Bill Matthews' official scoring games and to see what he did as official score, but you can also break it down any number of ways. But this infrastructure goes back a long time, but I don't think they were keeping track of the weather in the 19th century. They were keeping track of the start times and the end times, and they would keep track of the time of year. But this is only really in the 1980s.
From this from this, and this is a recent
Yeah. this-
game, but from this format, you could reproduce, if you wanted to, the pitch count.
Oh, yes. Oh, yeah.
But I don't, when did you say this format came into?
So this is from 2015.
This, writing down every pitch.
Oh, this is from about 1984.
So I'm just wondering whether you know when pitch count became kind of a big deal or
Right. So so one of the interesting things you can do is you can start and work back when statistics, i.e. measures of quality or measures of ways of making judgments about strategy. So pitch count being a classic example of a modern way to measure strategy, using not the pitcher's physical demeanor on the mound, but actually how many pitches he's thrown as a measure of whether to take him out of the game. That comes in mainly in the 2000s, but it starts to kept track in the 1980s. So it's a similar kind of story about keeping track. But they something like pitch count, it's only not just when they've kept track of it, but then when they've correlated it with certain kinds of outcomes do they start to care. Yeah, so pitch count you only hear about much more recently. But they've kept track for quite a while. Yeah. All right, so that's one number. The other number is a little faster here, which is the origin of this 65.5. The origin of this single number on top of a Major League Bureau, Scouting Bureau free agent report. So where does this come from? Before the 1960s, really, scouting was kind of a free-for-all. So each team would have scouts. This is going back to the 1910. Each club has a scouting force. This is one of the earliest uses of the word, of veteran players or retired owners, whose duty was to scour the entire country seeking men who by their playing show promise. This is the kind of idea. Scouting comes from a military context. Generals would send scouts out to see where the enemy was, to explore the terrain. They used that explicitly, borrowed it for something like baseball as a kind of to scout out who the best players might be. Scouts before the 1960s are essentially not just in charge of finding the best players, but of signing them. And this changes dramatically in the 1960s. And it changes because of the free agent draft. But to give you an example of what happens before this is a scouting report from 1964, and it's essentially a letter. This is a classic scouting report pre-draft. And what you can see is Herb Stein, who's scouting a player called Rod Carew, who would go on to a distinguished career. And this is the kind of language that's used. I've seen this boy in a number of games during this period, and the following evaluation is submitted. Physically, he has a fine body, wiry type, he has no known injuries or physical defects, etc. They would describe his body, describe what kind of player he might become. And then the key aspect is money. And essentially it was a negotiation about money. So he was going to offer a cash bonus of $5,000. That's a lot of money for players in the 1960s. And an incentive bonus about $400 per month in addition. And so what scouting reports were in the 1950s and early 1960s is essentially negotiations over money that came down to expense reports. You filled out scouting reports because you had expenses to report on the players you signed. And the central club or the central team would want to know what kind of expenses you were incurring. This changed, though, after the free agent draft. Now, the free agent draft was instituted because teams were tired of paying out these bonuses. And so the idea is if you institute a draft, then each team has one chance of selecting a player. You go through all the teams, and then you select again. And once a player is drafted, he can only sign with that team for the following months to year until the next draft occurs. And so it's a way of keeping bonuses down, because if you choose not to sign with that particular team, you can't play professional baseball in the United States. And so you are able to reduce the amount of money you have to spend on players by drafting them in this process. But once a draft comes into effect, scouting now has been fundamentally changed, because no longer are you going out and finding a Rod Carew and negotiating how much to pay a Rod Carew. Now what you're doing is filling out reports on players that may or may not get drafted by your team. And so you no longer can simply say this player is worth $5,000. You also have to find a way of signaling to your team when or how they should draft this particular player. And so one of the institutions that's created in this period is called the Major League Scouting Bureau. And the idea is that instead of every team trying to find every player, they would pool their resources into a central bureau. The bureau would then be able to go out and create reports on many of the players around the country, and then teams would all have access to these reports. They could rely on them in making their own choices about drafting. Because no longer did it really pay off to develop a hidden gem, because chances are some other team would also know about that player, and the chances of you being able to draft that player were much, much lower. And so the investment in a kind of personalized scouting business was reduced dramatically in this period. People were willing instead to have a kind of bureaucratized, centralized scouting. But the key thing for this story is that it changes the way you think about numbers in baseball, because numbers go from being fundamentally about money, about how much is a player worth, to being about rating, to being about valuation, other modes of evaluation. And so the core of every scouting report now became numerical evaluations of skills. So you can see here, every skill is rated, and they're rated both for the present value and for the future value. The Major League Scouting Bureau also instituted a 2 to 8 scouting scale, and the whole idea was that it would be on major league standards. So someone would be evaluated as to how they would play in the major leagues right now. I suspect, although I have no evidence, sadly, to prove this, I suspect this was related to the SAT, which is becoming increasingly popular in exactly these years, also on a 200 to 800 scale, normed around 500, just like this is, but I've never been able to find the smoking gun, and the people who created the reports have no memory of where they got that particular scale from. But at least that they've told me. So in any case, this becomes the core of the report. It's a way to reduce skills to numbers. And more than that, they wanted to turn these numbers now into some sort of mode of judgment. And so teams in their scouting reports would start to provide ways of connecting what they see visually about players to the numbers they should put onto a report. So this is an example from 1990, a much more recent example from the Chicago Cubs. But for instance, if you want to give someone between a 70 and a 79, here's the sort of expectations you should have. They should walk about 1 person per 9 innings if it's a pitcher. Should have a velocity in the 90 to 92 mile an hour range. For a hitter, about 290 to 309 hits. These are quite specific. And also the irony is that these are on a major league scale. So if you're watching an amateur play, you're having to try and predict what would happen if this person were playing Major League Baseball. And of course, you have the timing of running as well for speed. And one of the things they acknowledge, though, is that judgment never goes away. So even something like a radar gun, they say different radar guns give different readings of speed, and it also depends on where the pitch is. And so one of the things I want to emphasize is that it's not that judgment is eliminated, but it's that judgment is turned into an interaction here with numbers. Putting the numbers on particular skills require a level of judgment as to how to turn something like a speed gun, a radar gun, into a particular number.
But this is no longer, you're no longer talking about what the scouts are doing, you're talking about what the Cubs are doing and what the Chicago Cubs are doing.
So this is what the Cubs are teaching their scouts to do. So this is in their scouting manual.
So the scouts are working for the league now.
Right, so the Chicago Cubs still have their own scouts as well. So the scouts, I should have been clear, scouts now are both working for teams. There's some teams have their own scouts, but there's also a centralized bureau.
So the teams are, in spite of trying to pool the efforts, they're still double guessing the...
Exactly. So the way they would use the bureau, some teams like the Cubs, for instance, would get the reports from the Major League Scouting Bureau, and then if the particular player looked promising, they'd send their own scout to see that player, to have another report written on the scout. Does that make sense?
Yeah.
Okay.
Kind of seems like it was defeating the...
the bureau. It was defeating in a sense, but what's a kind of, they never trusted the bureau reports completely, and that's a point I want to come back to in a way, is this role of trust here in the use of these reports. One of the things that you can see, though, is that every team adopts the same scales. And so because they want to make their reports commensurate with the Major League Scouting Bureau, they all teams adopt the 2 to 8 scale. And then in particular, they adopt this overall future potential metric.
So they're using the same form.
So they use exactly the same forms. This is a Major League Scouting Bureau, this is a Scouting Bureau form. But you can see the forms are all the same here, and all the teams start using them. All they'll do is photocopy them and change the name at the top, or they'll adapt them for their own purposes by maybe having slightly different categories. But essentially, it's the same report after the Major League Scouting Bureau comes into effect. How did they calculate the overall future potential, excuse me? Well, it was meant to be a number between 20 and 80 that reduced this entire report to one number that was indicative. The problem is that scouts would have first just give that number to players without connecting it to any of the grades that they had given. And so the Major League Scouting Bureau became very upset at this, and it said they wrote a letter to all their scouts. After the January draft, it became apparent that the overall future potential number was not compatible or relative to individual numbers used in grading a boy's various skills. All players are referred to as boys. That's the general terminology for a prospect in this period. We gave this a great deal of thought, my favorite line, and on the following pages is a formula which we think will help our scouts come up with the right numbers if they choose to use it. Of course, in dealing with human beings, there are absolutely no mathematical formulas that will always get the job done right, but it is a guideline to use. And so they know that it's a problem, and so what they said is that what you should do is you should take the first numbers here, all the way from hitting ability through range, you should add them up, average them, multiply by 10, and then you can use these last two numbers to adjust it up or down up to 5 points if it's not consistent with what you've seen. And so you have a basic overall future potential, which is essentially the average of what they consider the skills, and then you have an adjusted overall future potential on the basis of instinct and aggressiveness in this particular case. And now you have a single number. Essentially, the various skills have been reduced into this single number. So it provided, for my purposes, in kind of a history of numbers sense, it provides a way to mechanically move from the grades you give to an overall future potential, to a single number, but without reducing the role of judgment. You still need to make the judgments for these original numbers, and so it serves both purposes. And then, of course, teams also would send out these cross-checkers. This comes to Glenn's question, that not only did they have their own scouts, but then they had a kind of hierarchy of scouts. So they could send out cross-checkers to check if there was a particularly promising player, or if they were going to spend $1 million on a player. They wanted to make sure they had a number of different reports on this player to see a number of different scouts actually rate the reports and provide an overall future potential. So from a history of numbers perspective, we can raise the question, why quantify, right? Why did they use numbers in this way, especially in this kind of what seems to be an irreducibly subjective kind of evaluation? And in essence, I want to push back a little on two classic examples of the use of numbers. And one is Ted Porter's argument in Trust in Numbers, that numbers are used by weak groups. They're used by those who are out of power in order to gain power. That you gain power essentially by becoming more objective, by using numbers in this way. And then there's also Des Rosiers' argument that numbers are used in the opposite way. They're used by people in power to maintain power. And instead, I want to suggest it's a kind of much more mundane use, that the history of baseball suggests that numbers were really much more about bureaucracy. They were about ways that clubs and leagues could turn individual judgments into useful numbers. You needed to know who to draft first. Knowing that there were 50 players that were pretty good or 50 players that were excellent was not enough. You needed to have a rank order list. And numbers in this sense operated in this bureaucratic mode, that they could take these individual judgments, these irreducibly subjective judgments, and turn them into a single number and therefore into a draft ranking. I think we also learn a number of things about the number that gets used here, this overall future potential. And the first aspect is that it's never impersonal. It's never a replacement of people with numbers. And one way we know this is that people cared about who wrote the report. They cared about whether the report came from the Scouting Bureau or whether it came from their own scouts. And they were worried about these reports from the Scouting Bureau because they thought the Scouting Bureau would be trying to write reports for everybody and therefore write them for nobody. And so one of the things they described, or one of the scouts, described evocatively the Bureau reports as faceless reports. They were faceless reports because you didn't know who they were writing for and you didn't know the person writing them as well as you would your own scout. And so it's a reminder that even in this mode of reducing a kind of complex subjective judgment to a single number, they still cared who signed the report. It was always someone's judgment. And so this is not an instance of numbers being used in lieu of personal knowledge or to replace a kind of subjective expertise. And the second thing is that it just is a single number. This is a classically kind of modern, we all recognize this, the use of one number to stand in for some sort of complex entity. So I think about this in terms of credit scores for job applicants, or blood pressure guidelines for hypertension diagnoses, or thinking of public opinion surveys standing in for a certain kind of belief or a certain kind of trust. So this is the reduction of complex phenomena to a single number is a kind of modern, classic, mid-century move across many different disciplines that scouts were participating in. The third aspect that I see in it is that it's never about the elimination of subjectivity, but about mobilizing it. And so I think of this as, so for instance, think about mid-century efforts to have a pain scale, a scale by which you could turn judgments of pain into statistical measures of a difference. Or you can think of it as wine tasting. I've worked on a project on wine tasting, where how do we know the difference between somebody who says a wine is good and somebody else who says it isn't good? Well, you can ask them to provide numerical measures and then use standard measures of statistical significance to determine difference, to determine distinctions between them. Scouting, I think, is a similar mode of dealing with an action that is inherently and irreducibly subjective. That is to say, one human being watching another move around a field, but yet mobilize it in a way that can be useful in a complex bureaucracy. And so it has all the hallmarks of a kind of data-driven science, no differently, I think, than Pete Palmer and his database, which is to say, you use existing data, you're continually adjusting inferences on the basis of new data, and you're searching for meaningful patterns in the data. That's exactly what historians have started to talk about, the rise of these data-driven sciences or data-based sciences in this period. And the final thing that is of interest to me about this particular number is that scouts here are not complaining about statistics. Scouts are complaining about numbers in this entire period, but they're complaining about their own numbers. And this is a kind of underappreciated aspect. So scouts themselves describe scouting as more of a numbers game now, and it's too scientific all of a sudden. And so what they're complaining about is actually the restrictions put on themselves. They're complaining about the fact that everything they do now has to be expressed in a numerical form. And so when we set scouts as opposed to a kind of statisticians or a kind of scorer, we miss this aspect of scouting. All right, so a few final thoughts on what we might learn from thinking of baseball in this way. The first thing is that I want to suggest that these two modes, these kind of classically distinct modes of scouting and scoring, are actually far more similar than different. And I think this is true for many different practices. For one thing, they're bureaucratized. For another thing, they both rely on judgments, and in particular moral judgments about what counts and what shouldn't count. They rely on human labor, an extensive amount of human labor, and the organization and management of human labor, and then a kind of technological expertise, whether that expertise is learning how to navigate a scouting report or whether it's learning how to navigate a score sheet. Or, of course, the different levels of computing that are in both cases. What else can we take from something like this? I think it also reminds us of the meaning of data, that data was never meant to be something numerical or something objective, that data etymologically is just that which has been given. It's what you assume in order to make an argument. Both scouts and scorers use data in this sense and think of the numbers that they are producing as data in this far more traditional way of data. Of course, now we think of data as that which an investigation produces, but it had the exact opposite meaning originally. It was that which you took for granted before you had an argument or before you engaged in a particular discussion. Yeah?
I didn't get it. The scouts were taking for granted, or the scouts were producing data? Which one?
Exactly. So what they're thinking of is data here is that which is produced by scouts, but then used for the argument about who to draft. And so it functions here on both sides of the etymological divide. It becomes data when you're talking about who to draft, but it's data that is produced in the way we're familiar with the production of data.
So you're kind of putting, so a give is a transitive verb, and there's a subject and an object, and who's doing the giving.
Exactly.
So they're kind of used to thinking about being on the receiving end of it.
Mm-hmm.
Data
just comes to you.
Yeah, but there's somebody producing the data. That's what your point is here.
Exactly. I want us to think about that dual aspect, that is both that which is produced, the effort that goes into its production, and also that data is just whatever counts as that which we've accepted or which we've been given. The second aspect I want to raise is that it's not an insider-outsider distinction. This is one of these stories that gets told about data analysis, that it's about outsiders toppling a kind of insider narrative, that it's the outsiders armed with data. And this is certainly the way Michael Lewis has portrayed Moneyball as being about outsiders and renegades attacking the club, this kind of clubby insider expertise. And it's also the way historians of big data often talk about the ability of big data to undermine a kind of superstitious or conventional thinking and disciplines. That only when you have this kind of mass of data are you able to cut through the stale ways of thinking and disciplines. But I think the history of scouting and scoring and the history of baseball in general suggests that it's not really about outsiders challenging insiders, that both insiders and outsiders are mobilizing numbers, they're mobilizing data in a way because they have this problem that they need to make reliable decisions, and they need to turn a kind of messy world of bodies moving through space into a clean world of data. And that process itself is not about insiders and outsiders, but about making reliable judgments about seemingly subjective or irreducibly subjective activities.
So if I ever get around to reading Michael Lewis's book, should I believe what he's saying?
You can believe what he's saying, but I think we need to recognize these myths as myths. That is to say, the idea of data being deployed, kind of numerical data being deployed by the Davids going after the Goliaths of the world as being a useful myth to create a kind of account about how data can topple received expertise or received wisdom. But that's essentially what it is. It's a story that's created that I think in order to create a story like that, you have to ignore all the forms of data that are being created by insiders for their own purposes. Which leads me to the question of expertise. So one of the things we know about our world is that we're in a world where expertise is declining. And so in fact, there's a book out called, helpfully, The Death of Expertise this year. But there's also, this is a kind of overview of big data, the so-called revolution that will transform how we live, work, and think. Victor Meyer-Schoenberger and Kenneth Coukier's book on big data. And they describe baseball analytics, the kinds of material that I've been talking about, under the heading, The Demise of the Expert. So it's quite clear that this is a story about the end of expertise, that data-driven decisions, as they say it, will overrule human judgment, and subject matter experts' supremacy will ebb. And we're told this is going to happen in all sorts of realms, everything from making medical diagnoses to flipping burgers. We're no longer going to have to think about them because we're going to have machines to do that form of thinking for us. So we're familiar with this rhetoric. We're also, I hope, familiar that it's very old. So the example I like to bring up is Carl Pearson in 1911, also describing the end of expertise. In 1911, the day of authority in any branch of science has gone by, and we ask legitimately and instinctively instead for the data. And this is his famous passage of statistics on the table, please. Stop talking about expertise and give me your numbers. And so this is an old kind of idiom. And so I think for one, we need to recognize it's not about the demise of expertise, it's about the replacement of one form of expertise with another form of expertise. Of course, that's really what we're talking about here when we talk about the demise of expertise. But I also think that there might be another way of thinking about this, which is to say that when data is so widely available as it is now, recent debates kind of showed the power that people with a little bit of data can wield. So I'm thinking here, for instance, of claims of voter fraud in American elections over the last couple years. For example, are based in inferences from small segments of national survey data. And although it might surprise us initially, I think it fits this kind of Moneyball story almost precisely, which is to say it was about the use of numerical data by outsiders that contradicted insider expert judgment in order to make a surprising claim about the power of data in the modern world. And as with climate change or cancer before it, we know from historians of science how powerful a small group of people can be effective at sowing doubt. That is to say, you don't have to prove your case, you simply have to show doubt about the expert judgment in a particular case. And so although it's a long way from Moneyball to, say, alternative facts, as they're now called, I do think that if we look at 2016 Word of the Year, post-truth, by the Oxford Dictionaries, the definition that Oxford Dictionaries get is exactly this dichotomy that we saw in baseball, which is to say relating to or denoting circumstances in which objective facts are less influential in shaping public opinion than appeals to emotion and personal belief. And so again, you see this kind of splitting between objectivity and personal belief that is the claimed distinction between scores and scouts that I'm trying to push back on. And so I'm not suggesting that data scientists are somehow in the post-truth business, but I am suggesting a lot of the rhetoric about the demise of the expert has perhaps made it harder for objective facts to triumph over personal belief in a world in which everyone can be a putative expert. And the final thing I want to say is just, this is a reminder that we know the human sciences are increasingly becoming data sciences, but we also need to think about the data sciences as irreducibly human sciences. And that's a two-way street, I think, and the example of the scouts and the scorers is a good reminder of this. And perhaps this is all too much to put on baseball. After all, it's already a religion. It's already a kind of cultural marker, a model for rationality. But hopefully something as mundane as baseball gives us new ways to think about some of these bigger questions in the history of data and in the future of data. So thanks very much. Let me